Hello, my name is Howard Cook. I'm one of the owners and the founder of Bay Area Retrofit 25 years ago. And I'd like to talk to you about probably the most critical connection in any cripple wall retrofit, and that has to do with the connection of the plywood to the bolted mudsill. In order to make that connection, there are framing modifications that have to be made. There are 4 different ways of doing this, and I'm going to show you what all of those are and why it's so critical. Let's go ahead and see what the problem is. So right here we have this is the mudsill. These are almost always 6 inches across here, 2x6s, and right here this will be a 2x4. In the old growth stuff, this was 2 inches. And then this piece of plywood, you can see that if we put the piece of plywood on, it just sits on top of the mudsill right along here, and it's not connected to the bolts. So that's what our big issue is. How do we make sure that this plywood is connected to the bolts? And we're going to look at the different ways to do that. So here's a photograph of the exact same thing. Here's our mudsill, which is probably 6 inches. Then here's our 2x4 right here. And we need to put the plywood in so it is connected to the bolts. So the way we have to do that is we have to make sure that that piece of plywood is well connected to this piece of wood. As it is right now, if we were to put a piece of plywood here, it would just sit on the edge right along here, exactly as we saw right here. And that just doesn't, that's just not going to work. One way to do that is by flush cutting the mudsill. Here's our situation that we saw before. This is a 2x6 across here. Then there's a 2x4, so that's 4 feet right here. And if we put a piece of plywood on, it'll just sit right on top and not be connected to the bolts. So with a flush cut system, what we do is we flush cut we take out a piece of wood right here, and now this mudsill right along here is flush with the 2x4s right along here, which is also flush with the top of the cripple wall right here. So now in this circumstance, we can put a piece of plywood right across here and nail it here, and nail it here, and nail it here, and nail it here. The big advantage of this is that this is a well-tested system. The American Plywood Association, which is responsible for all the testing in the country, for Canada and the United States, this is how they tested them. They had 2x4s on the top, sides, and bottom. So this is, you could say this is the best tested method. It's not the only method, it's not the only effective method, but it's the one that simulates tested methods. So this takes a special saw. We actually have them custom made just for us to do this because we consider this method to be so effective. And let me just show you what's happening here. This is the 2x6 mudsill. This is the 2x4 stud that goes up and down in the cripple wall. And what we're doing is we're cutting the mudsill right along the edge of the 2x4, and then this piece of wood we're actually going to take out. So this is what it looks like. Right here you can see how the section of mudsill has been removed. Here's our 2x6. And this section was removed right here, so that now the edge of this mudsill is flush exactly with the 2x4s. And here you can see how someone took the piece of mudsill out as a piece. So here you can see how it was cut off. This is the 2x6 right in here. We've converted it into a 2x4 going this way. And now when we nail our piece of plywood along this edge right here, we're going to be nailing the plywood directly into the bolts, which is exactly what we're trying to do. So here you can see our completed plywood installation using the flush cut method. The bolts are right behind here, so behind the plywood here, and there was another one here. And these holes are there so you can actually see the bolts, so that when the job's done, somebody comes and looks, they can actually see what we did. So here you can see all the nails right here into the flush cut mudsill, which is right where we want them to be. So this is one of the biggest advantages of using the flush cut method. The tendency for a nail to withdraw from wood, which is what happens when a shear wall fails. As the plywood buckles, it pulls the nails out of the wood. And we have this old growth wood where it has very, very tight growth rings. They resist that withdrawal better than tree farm wood. So what you see on the left is the old growth wood that the older houses had when the redwood trees were still around. And the one on the right is from a tree farm, which has very, very few growth rings, and nails will withdraw much easier than using the old growth. So that's one of the big advantages. So this is called the reverse blocking method. In this circumstance, what we do is we take a 2x4 right here, and we attach it to this piece of plywood by putting nails in from the back. So the plywood is nailed where you can't see the nails coming in this way. Now we take this whole assembly and we put it right here on our cripple wall, and we nail it through the 2x4 into our mudsill. And then we'll also nail all the way along here and all the way along here and all the way along here. And this is actually one of the ones that's on the most preferred list. We actually had these evaluated by a very high-powered engineer who did research on these things. And he said this is also a very good one because it also mimics the tested systems, which had 2x4s on the top, on the sides, and on the bottom. So it's just another way of doing a very good connection to the mudsill. So here's a photograph of a reverse block plywood connection. Here's the 2x4 that we were talking about, and this plywood has been nailed to it from the back like this. And so this is either, I'll show you here, here's the mudsill right here. Now what's critical is that there has to be enough mudsill right here. Probably 2.5 inches would be the best. It depends on whether you use nails or you use lag screws. This is actually a lag screw right here. You can either use lag screws to connect the 2x4 down into the mudsill, or you can use nails, and we're going to go over that in just a little while. But anyway, this is what they look like. They are very effective, very easy to install. You don't have to cut a bunch of blocks. Lots of advantages to these. So here's more of the same thing. I wanted to show how you can actually use these special type of foundation anchors. These do the exact same thing as a bolt. So again, you can just see how this 2x4 was back nailed from the back right here, and then here's a lag screw that shows how it was nailed down like that. So just to show you how this is a good example of what's called the load path. So what happens is here, this is your floor joist, and this right here is a shear transfer tie. So as the floor joist moves this way, it pushes against the shear transfer tie. The shear transfer tie in turn pushes against this upper top plate, which is right here. That in turn pushes against the nails, which are in the top of the plywood, which in turn pushes against the bottom row of nails, which is behind this 2x4, and then that goes into the lag screws. There's one here and one here and one here, and then that pushes against the mudsill, and then there's a bolt right here to resist that. So that's what's called a load path, and this is how reverse block shear walls use that load path. So this chart actually tells us when we're using the lag screws, or lag bolts as they're called, how we need to install them. They're kind of sensitive in terms of the distance between the ends and between the edges of the plywood. So of the 2x4, so let's go ahead and look at that. So this is the edge distance, and edge distance means the edge of the 2x4. It's usually the 1.5 inch section, and we're always going parallel to the grain. And we're going parallel to the grain. We have to have a minimum edge distance of 1 inch. This also tells us the spacing between our lags right here, between fasteners in a row, can be 3 inches or more. So let's go ahead and see what this looks like with a real world example. So the distance between these lags can be 3 inches or more. So from here to the next lag can be 3 inches or more. It's just like we show right here in this drawing. The lag screw spacing along its length. This is its length right here. And be 3 inches. Here's a lag, and it's got to be at least 3 inches and no less than that. Otherwise, they're worried about splitting. Now this right here is the piece of plywood that's the same as this. And what it tells us here is that the distance between the lag and the edge of the 2x4 has to be at least 1 inch. So that means along this edge of the 2x4, coming across this way, between the lag and that edge has to be 1 inch. It also tells us that the distance between the edge of the mudsill and the lag screw also has to be 1 inch. So right here, this is the edge of the mudsill, and so the edge of the mudsill and the lag screw that's coming down right here, that also has to be 1 inch. So it's probably about, you know, between here and here. That has to be 1 inch. Now we don't worry about this edge right here because it's always, you know, it's sticking out beyond the mudsill right here. So anyway, that's how all the spacing works in one of these reverse block mudsill connections, and you just have to be careful about these things. And so long as everything works out so that you can make all these edge distances, you should be just fine. It's a great system and well tested. Again, it's got 2x4s on all sides, and so between this and the flush cut method, you know, these are really the ideal ones. So just like with the lag screws, we need to look at edge distances and spacings with nails. The first thing we notice is that the edge distance for nails is 2.5 D. Now D is the diameter of the nail, and what we use 12D commons, they have a diameter of 0.148 inches. So we would just multiply that times 2.5 and we get 3/8 of an inch. And that is what our edge spacing can be. So from the center of the nail to the edge of the 2x4, we can have 3/8 of an inch. The next thing we want to look at is the spacing between fasteners in a row. A fastener is a nail in this case. And we always look at parallel to grain. And here it tells us that we need 15 diameters between nails, and that's 2¼ inches. So what that means is we put in a nail, and then we want to put our next nail in at least 2¼ inches from that, and then the next nail 2¼ inches from that, and we're putting these all in a row. So just make sure they're 2¼ inches apart, and you'll be perfectly code compliant. Now the next thing we need to look at is spacing between rows of fasteners. So we have one row, so we've done, you know, a nail, then we went 2¼ inches, we did another nail, 2¼ inches, another nail, we all did them in a straight line, and we want to put another one right next to it. And if we want to do that, the 2 rows of nails have to be 5 diameters apart, and 5 diameters is 3/4 of an inch. So we take 3/4 of an inch between the 2 lines of nails, and once we do that, we're perfectly fine. Now, if we stagger them, in other words, we put a nail, one row of nails is offset from the other row of nails, then we can go 2.5 diameters, which is only 3/8 of an inch. So we can get a lot of nails in a fairly narrow, strip of wood and be perfectly code compliant. And this is actually quite handy with reverse blocks because sometimes we just don't have, enough to use the lag screws. Hello. So let's go ahead and look at a reverse block installation and see how these limitations on the nails actually play out. So let's go ahead and look at this. This is the 2¼ inches. This is the same as this parallel to grain spacing of 15 diameters. So what that means is the distance between the nails, let's say nails here, and one that's in a straight line would be 2¼ inches. So this is actually B1 here. 2¼ inches would be probably about here, another 2¼ another 2¼ So we can have a straight line where they're all at 2¼ inches apart. The next thing we see is this distance right here. That's the 3/8 of an inch. That is the same as the edge distance of the 2.5 diameters. So this 3/8 of an inch edge distance means the distance from this edge, and this is the same as this edge right here. So you see this is the plywood right here, this is the plywood right here, and where they come together with the 2x4, which is right here in this corner, that is the edge of the 2x4 right here. So the distance from this center of this nail to the edge of the 2x4 can be 3/8 of an inch, exactly as shown right here. Now the mudsill, which is right here, is also 3/8 of an inch from the edge. So if we were to look underneath and in this direction, we would be able to see the mudsill. As you can see right here, it's covered. So right underneath this 2x4 is the mudsill, but again, if we were to look in here, we would see it. And the distance from the edge of that mudsill to the nail, you know, here's a nail right here. Let's say the mudsill is right here, the edge is right here. They cannot be any closer than 3/8 of an inch. Now, as far as the spacing goes, right over here it tells us if they're in line, we can have a spacing of 5 diameters. 5 diameters actually is 3/4 of an inch. So what it's saying is if we can put one here, we can go over, and then we go 2 1/4 inches, 2 1/4 inches, 2 1/4 inches, 2 1/4 inches for our line of nails. And then if we come over here at 3/4 of an inch, we can put another line of nails, 2/4 of an inch, 2/4 of an inch, 3/4 of an inch, 3/4 of an inch, 3/4. Now, if we stagger them, just like you see here, where there's a nail here and a nail here and a nail here and a nail here, we can actually make this distance between the rows just 2.5 diameters, which is 3/8 of an inch. So we can get more nails in if we can stagger them. So we can really get a lot of nails in a 2x4 if we need to, and this is often the best way to do it, because sometimes you only have a narrow strip of wood that we can work with where the edge distances apply. So anyway, that's how the reverse block systems work, and that's how you fasten the mudsill. So right here is the chart from the manufacturer of the lag screws, the Simpson Strong Tie Company. And this chart tells us what the shear strength or earthquake resisting value is of their hardware. So let's go ahead and take a look and see how we read that table. So what it tells us first is that we're going through 1.5 inch 2x4. So that's what we're going through with our screw. And we're going to be using a 3.5 inch lag screw, 1/4 inch diameter, 3.5 inches long. And when we do that, it's 245 pounds of earthquake resistance if it's in Douglas fir. Now, Douglas fir is what it was tested in, and you have to modify it a little bit if you're going into redwood, and we'll talk about that in a minute. So that's what it can resist. Now, we also have to look at the another factor, and that's the specific gravity. So if you come right down here, it says where the side and main members have different specific gravities, the lower specific gravity shall be used. Now, the side member is what you go through. So in that case, it's the 2x4 we're going through, and the main member is what it's going into, which in this case is the redwood mudsill that's 2 inches thick. So they have different specific gravities. One must multiply the 245 times 0.88. So that's what's called the reduction because of specific gravity. Now after that, we have to look at something else, and that here is this 1.60. That's the load duration multiplier. And I don't want to go too much into the definition of a short-term load multiplier, except to say that we multiply everything times 1.6. And the final result is that our lag screw can resist 344 pounds of earthquake force. So let's go ahead and see how that works. So we just looked at using the reverse block method and lag screws, and now we're going to look at it when we use nails. So that's about all there is to know about the reverse block method. We did have this looked at by the largest research laboratory in the country, American Plywood Association, and they said this is a very effective method, along with the flush cut method we just looked at. Right now we're going to be looking at the nailed blocking method. This is a method that's used by practically all contractors. And the very interesting thing is it's also used by all the seismic retrofit guidelines published by the government. So this is a very important one. You're going to come across it when you talk to other contractors, and it's something you need to know about. So here we have our most common framing configuration for cripple walls. And this right here is 6 inches wide. This right here is 2 by 4. It's 4 inches wide, and so we've seen that many times. So as you can see, when we put the plywood up, it'll just be sitting right on top of the mudsill and will not be connected to the bolts. So what we do in these cases is we put a blocks here. So here's a block, here's a block, here's a block, and here's a block, and then we put the bolts straight through the blocks into the foundation. We put one here and we'll put one here. And then the piece of plywood can be nailed directly into the blocks. So here we see the plywood has been nailed into the blocks, and up here and up here and up here. And so it's all in one plane, and it is connected to the bolts. So here's a photograph of a guy putting in the blocking that the plywood is going to be nailed to. I don't know where they found this guy. Nobody in this trade is that big. You can't crawl around under houses like that. So they must have gotten this guy from Hollywood. But anyway, it is showing you what you need to know. The problem with blocks is they'll split. Doesn't take a whole lot to make them split, especially when you're using a nail gun. And a lot of times contractors are, they're kind of in a hurry. So they want to, get the blocks in there and, get out. And so oftentimes what they'll do, because the blocks do split so easily, they'll put in smaller nails. We've taken a lot of shear walls apart and taken the blocks out, and a lot of times they have nails that are too small, for what's actually required. The other problem is that sometimes they just won't put in enough nails, and we're going to go ahead and look at all those problems right now. So as you can see right here, this nail caused this block to split. Looks like there's another split over here, and there's also a split over here and a split over here. Come here to another block. You can see here where it's split. Another nail caused it to split right here. Exact same thing here. This nail on the end caused it to split right here. And right here, this is a block that we looked at, and what they did so that it didn't split was they put a nail right here and a nail right here, even though you need to put a lot more nails in there. There should be at least 4 very large nails, to make this effective. As mentioned earlier, all of the existing seismic retrofit guidelines recommend the nailed blocking method, and I'm going to show you what those guidelines are. So this is from Appendix Chapter A3 of the existing building code, and it's actually in the California existing building code as well. So this is something that's been adopted statewide, and as you can see, it does require blocks to be nailed to the mudsill. Here's the guidelines from the City of Los Angeles. You can see here where they're also requiring the nailed blocking. This is from Standard Plan A. That's a regional standard, also accepted by the California Earthquake Authority in their grant program to do seismic retrofits. As you can see here, it also requires nailed blocking. And this is FEMA DR-493, and it was created after the Napa earthquake, and as you can see, it also requires nailed blocking. And this is from Seattle's Project Impact. That is a guideline that is used by the City of Seattle. And so as you can see right here, these dots actually represent nails. So there's a dot here, a dot here, a dot here, and they have 4 nails, just like all the other guidelines require that 4 large nails be put into the blocks. And finally, we have the most recent one, and that is Fema P-1100. Now, this has a change, a fairly significant change, in that it also allows screws to be used instead of nails. And that's a big deal. because when we see how this was evaluated by the American Plywood Association, this was actually recommended over nails. So this is quite an improvement, this particular recommendation right here. So this is what a block looks like that uses the self-tapping screws. As you can see, we have one here, we have one here, and one here. And these can resist about the same as 2 nails. So this is the equivalent of 6 nails, and as you can see, there's no splits. There's actually no danger of splitting. We could probably put 5 or 6 of those in here and we wouldn't have had any problems. So these blocking like this is a very viable alternative. Now right up here you can see how we have a whole set of them. This is all set for the plywood. Naturally this pipe will be removed before we can put the plywood up. But anyway, this is a very viable alternative to the other methods we looked at, and certainly a lot better than the nail blocking method that all the guidelines use. Sometimes you do need to use blocks, and in this case the best thing to do is use staples. So here we have some staples. They're 2.5 inches long. They go through the block, which is 1.5 inches thick, and so they go a full inch into the mudsill. So we have a stapled block here, one here, and one here that the plywood is going to be nailed to. The great thing about blocks and staples is they don't split. So you can see all these staples in here. They're worth a tremendous amount of force. I mean, they can resist a lot of force. Each one probably 50 pounds each. If you can put in as many as you want, you could put in enough to resist, 10,000 pounds per block. It's just amazing how much, how many staples you can put in a block without it splitting. When I was a member of the International Code Council Committee writing the retrofit standard called Standard Plan A, I had access to engineers and other professionals I would not normally have access to. And so one of them was the lead research engineer at the American Plywood Association, and I asked him to please evaluate all these methods, and this is what he told us. He said the best method would be the flush cut method, which we just looked at. The second would be the reverse block method, which we looked at, the stapled blocking method, and then the nailed blocking method. Now the flush cut method and the reverse block method are preferred because they most imitate the actual testing they did in their laboratories, where they would do a 2x4 and a 2x4 and a 2x4 on all 4 sides, and then they would subject it to a lateral force to see how it would perform. So those are the ones that are the most closely tested systems. And then he talked about the blocking. He said that the stapled block would be better because they would not split as easily. And then we also have the nailed blocking method. That is the least preferred because of the splitting problem that we just looked at. Now it's important to also look at what he also said here, and this is also something that we will do, is an alternative to either of these methods might be to use 1/4 inch self-dealing, self-tapping lag screws, which we also looked at. So all these methods are pretty good, but amazingly, well actually they're, some are great and some are not so good. The amazing thing is that all these seismic retrofit guidelines use the worst method. And there's a reason for this. What happens is, as soon as there's the first guideline, this happened to be Appendix Chapter A3, and that had nailed blocking, then all the other ones that came after that, they would say, oh, well, how did these people do it? And then they would just look in there, and then that's what they would do. They would never talk to contractors. They would never experiment, never do anything creative. So what happens is it just reincarnates over and over and over and over again, and it's still there. And the first guideline, Appendix Chapter A3, that is probably, I'm guessing 60 years old, certainly 50 years old. So it's half a century old, and they're still using the same method. And fortunately, the most recent one at least recognized the self-tapping lag screws, which is a huge improvement. And hopefully the next ones that come after these will show that the flush cut method is the preferred method, and of course the reverse block method as well. So anyway, that is all I happen to know about the way to connect plywood to the bolted mudsill, and I hope you found this helpful. I hope you enjoyed this video, and if you would like to hear about future videos, please subscribe. You can also email me at info@bayarearetrofit.com and ask me any question you like, and I'll do my best.